Yeah.
You've done a lot of thinking about morphological resonances of different sorts, and there's one that I've encountered that I really can't shake loose. I wonder if you have a comment on it. Reading about the brain, the estimates of the total number of neurons is about 100 billion. And as you read about cosmology, you read that the average spiral galaxy is thought to have 100 billion suns in it, and the total number of galaxies in the universe is estimated to be around 100 billion. And I recently encountered the estimate that the total number of biomolecules in a cell is about 100 billion. And it seems like this coincidence keeps coming up, and maybe it's related to Paul Dirac's idea of a large number.
Well, I think it is true that emergent properties come out of large aggregations. Always the textbook example is, if you have two H2O molecules, that's water, but you don't have wetness. Wetness doesn't emerge until you have thousands of H2O molecules. And so the wetness of water is a property which only emerges when you have millions of these molecules together. And it does appear that complex neural nets have to be above 9 billion operating subunits. And so, it may be that, definitely we are pushing toward criticality in any area of measurement. For example, if you look at the curve of energy release, or the population curve, or the curve of information production, or the curve of advancing velocity, you see that many of these curves will become asymptotic in the near future. And that's what I mean when I say we're headed into this domain of boundary dissolution and hyper-novel inflationary evolution, you could almost call it. Yeah.
Define asymptotic.
Isn't that, asymptotic is when it's not doubling every time you measure it. It's being squared, isn't that it, each time? Mm-hmm. So it goes logarithmic, asymptotic, and then there's another term for an even more rapid expansion. Yeah.